Welcome, my dear students. This is trigonometry part 18, extreme values of trigonometric functions. Right? We are having various trigonometric functions. We are going to discuss the extreme values of these trigonometric functions. For example, if you take here the first trigonometric function sine theta. See, the sine theta whose its range is actually -1 to 1. That means the minimum value is here. What you are going to get, the minimum value, okay, minimum value equal to -1 and the maximum value of sine theta is equal to +1, like this, right? We are going to have like this. First, let us discuss all the trigonometric functions and various different kinds of functions we are going to discuss. Similarly, if you take cos theta whose range is -1 to 1, that means here also the minimum value is equal to -1 and the maximum value is equal to +1. You are having like this. Next, you see, my dear students, tan theta, which is not included and it is lying between -infinity to infinity. That means minimum value will be nearer to -infinity. It will never take -infinity, but it will be nearer to -infinity. And the maximum value also is nearer to +infinity. It will never take +infinity because its value is not known to us. It will be nearer to +infinity, right? This is what you are going to have. Next, cot theta. If you take cot theta, this also -infinity to +infinity, whose range. Here also the minimum value will be nearer to -infinity and the maximum value will be nearer to +infinity. You are going to get, right, my dear students. Now, fifth one, you have cosecant theta. Cosecant theta is also, you know, that cosecant theta whose values belongs to, you know, that cosecant theta belongs to -infinity to -1, right, union 1 to infinity, right? That means that here also we can, cosecant theta will never produce the values between -1 and 1. Therefore, the minimum value is nothing but minimum value is also nearer to -infinity and the maximum value will be nearer to +infinity. We are going to get like this. Number 6, you are having here secant theta, my dear students. This is also belongs to -infinity comma -1 union 1 to infinity. That means here also the minimum value, because secant theta also will not produce values between -1 and 1, that you know that. Therefore, the minimum value is nearer to -infinity and the maximum value will be nearer to +infinity. These are the things, first basic things, the extreme values, minimum and maximum values of the 6 trigonometric functions we have got now. Now we have to discuss the squares of these trigonometric functions. Extreme values of sine square theta. You know, my dear student, actually sine theta is lying between -1 and 1. That means sine theta values belongs to closed interval -1 to 1. That implies that sine theta will be taking the values what, -1, -1/2, -1/3, -1/4, so on up to -1/9, 0, 1, 2, 3, sorry, 1. Okay, you are going to have, okay, 1/2, 1/3, 1/9, so on up to 1 we are going. When you do squaring of this, when you square this, what happens to that is nothing but -1 whole square become 1 and -1/2 whole square become 1/4, right? And -1/3 whole square become 1/9, like that, so on. That means the negative numbers also are transforming into positive values. Therefore, when you transform this squaring, what happens is that we observe that this value sine square theta will lie between 0 and 1. Therefore, you have got the extreme values. Minimum value is equal to 0 and the maximum value of sine square theta is equal to 1. Okay, therefore the range, okay, that is what range of sine square theta, this is equal to, we will be having closed interval 0 to 1. Like this we can understand. When you do squaring, there is no possibility of getting the negative value. That's why the range of sine square theta is 0 to 1. That is, minimum value is 0 and the maximum value becomes 1. Right? Now in the same way, the extreme values of cos square theta, the 8th one, if you discuss, the same logic will be applied as you know that cos theta is lying between minus 1 to 1. When same logic will apply like sin theta, when we are doing squaring this, now cos square theta will lie between 0 and 1. The negative values will be transformed into positive values. Therefore, the minimum value is equal to 0 and the maximum value is equal to 1. Therefore, you see here the range of cos square theta, range means minimum value comma maximum value, that is 0 comma 1. Like this you are having here, right? The extreme values of cos square theta, minimum value is 0 and maximum value become 1. Next we are having the 9th one, extreme values of tan square theta, my dear students. This tan square theta, you know that actually minus infinity less than tan theta less than plus infinity. That means tan theta values belongs to minus infinity to plus infinity. When you do squaring, that means when you do squaring tan square theta, you know that all negative values will be transformed into positive values. Therefore, the minimum value, because tan 0 is 0, 0 to plus infinity will be having here, of course. Therefore, 0 will be included because tan 0 is 0 and infinity is not included. Therefore, minimum value here, see here my dear students, minimum value of tan square theta is equal to 0 and the maximum value here, the maximum value of tan square theta is nearer to infinity. This will be nearer to infinity, is equal to infinity. That means it is not defined but it is nearer to infinity, right? Like this we are having the extreme values. Therefore, the range of, here you see my dear student, range of tan square theta is equal to closed interval 0 to infinity. That means open interval infinity. Like this we will be getting. Now the 10th one, in the same way we are having extreme values of cot square theta. Just replace the same ideology and the things we are going to get. In the place of tan theta, cot theta also lies between minus infinity to plus infinity. Now you are having here cot square theta, like this, cot square theta. Therefore, the minimum value of cot square theta, here the same logic will be applied because negative numbers will be transformed into positive numbers. Then there is no scope of getting a negative number. The minimum value of cot square theta is 0 and the maximum value of cot square theta will be nearer to infinity. Therefore, the range of cot square theta will be 0 to infinity. You are going to get 0 to infinity, where 0 is included and infinity is not included here. Now, the extreme values of cosecant square theta, when we are discussing here, my dear students, cosecant theta belongs to minus infinity to minus 1 union 1 to infinity. When we see, when you square this cosecant theta, that means cosecant square theta, these all negative values you are having, minus infinity to minus 1, they all will be transformed into positive, and minus 1 square is what the least value you are going to have. Next, minus 2 square, minus 3 square, these are all the values you are going to get. Therefore, what you are going to have is cosecant square theta belongs to 1 to infinity. Therefore, for this the minimum value is equal to, you are going to get it as 1, and the maximum value, here the maximum value is nearer to infinity. This is what, nearer to infinity, right? Fine. These are the extreme values of cosecant square theta. We are having like this. Now the 12th one, if you take the extreme values of secant square theta, like this, secant square theta. Now here secant theta belongs to, same logic will be applied here also, secant square theta, and here also you see my dear student, secant theta belongs to this same secant square theta is now 1 to infinity, minimum value equal to 1 and maximum value equal to infinity. Therefore, the range of secant square theta is nothing but Okay, 1 to infinity. Like this, we are having these different types of trigonometric functions, their minimum and maximum values. Next, when we are discussing regarding suppose extreme values of see my dear students, extreme values of sine cube theta. If you take sine cube theta, right, let us generalize this result. Of course, you know that actually -1 lesser than or equal to sine theta lesser than or equal to 1. When you do cubing on both sides, this is nothing but actually -1 cube and lesser than or equal to 1 cube. You are going to get the same thing. -1 cube is -1 and sine cube theta you are having here lesser than or equal to 1. That implies you have got that, my dear student, sine cube theta belongs to closed interval -1 to 1. This is what the range of sine cube theta. Therefore, the minimum value we have got here, the minimum value, right, my dear students, the minimum value equal to -1 and the maximum value is equal to +1, right? Like this, we are having this, right? Minimum value equal to -1 and maximum value become +1 for sine cube theta, right? Like that, we can generalize now the concepts for see this one, right? You see, for extreme values of sine cube theta, we have got like this. Now, if we generalize this fact, right, what we are going to have is now the extreme values of something like right, my dear students, 14. We are going to generalize, however, now after completing these. Similarly, for cos cube theta also we will do, and we will generalize these results. Even for cos theta also, if you see that it will be lying between -1 and 1, like that. When you do cubing on both sides, what you will be getting? -1 cube, and this is 1 cube you are having here. That is -1 cos cube theta lesser than or equal to 1. Therefore, the minimum value you are having as -1 and the maximum value you are having it as +1. Therefore, the range is nothing but -1 to 1, like this. The range is -1 to 1. Like that, 15th one, if you take the extreme values of tan cube theta, right? Extreme values of tan cube theta, like this. Okay, my dear students, if you just to take that tan theta, this is actually -infinity less than tan theta less than +infinity. You are having like this. That means when you do cubing on both sides also, this is now tan cube theta less than infinity cube. This is now -infinity less than tan cube theta less than infinity. Therefore, here also the minimum value of tan cube theta is nearer to -infinity and the maximum value is nearer to +infinity. Like this we have got for this one. And after discussing this, we are going to generalize these things. Now, 16th one, the same way, extreme values, right? Extreme values of cot cube theta, if you just discuss, right? What we are going to have is, similarly, this is -infinity less than cot theta less than +infinity. If you do cubing on both sides, what we are going to have, this is now cot cube theta less than infinity whole cube. This is now -infinity less than cot cube theta less than infinity. Therefore, here you have got the minimum value equal to -infinity and the maximum value is equal to +infinity. Therefore, the range of right, cot cube theta is nothing but -infinity to +infinity, right? Like this we are having these things. Now we have the extreme values of cosecant cube theta. You know that actually cosecant theta, where it belongs, you know that actually cosecant theta belongs to, right, from -infinity, open interval -infinity to -1 union 1 to +infinity, like this, right? That means when we do cubing also, cosecant cube theta will belongs to the same -infinity to -1 union 1 to infinity we are going to have, right? In the same way for secant cube theta also, secant cube theta also we can define, because okay, for secant cube theta, you know that secant theta also belongs to -infinity to -1 union 1 to infinity. That means when you do secant cube theta, this become minus infinity to minus 1 union 1 to infinity. Therefore, here also the extreme values here for cosecant cube theta, the minimum equal to, you have what, nearer to minus infinity, and the maximum is equal to plus infinity. Here also now for this the minimum is equal to minus infinity and the maximum is equal to at plus infinity. We have got these all the things. Now we are going to generalize this fact. Now the extreme values of sine power n theta when small n belongs to the natural numbers you are having here like this. Extreme values of sine power n theta when n belongs to n. You see, we have observed that sine power n theta is equal to this, actually this belongs to, right, this range, this belongs to 0 to 1 like this, 0 to 1 when n is even like this, because sine square theta we have observed, right, by our observation sine square theta belongs to 0 to 1 like this. Sine power n theta belongs to when n 0 to 1, right, and sine power n theta belongs to here what, right, we have here minus 1 to 1 when n is odd like this. When n is odd, this is what the range we are having here. When n is even, the extreme value, minimum value is 0 and the maximum value become 1. When n is odd, the minimum value become minus 1 and the maximum value become plus 1 you are having. In the same way, we are going to have the extreme values of, you see my dear students, the extreme values of cos power n theta, where n belongs to the natural numbers. That means you have here cos power n theta that belongs to same 0 to 1 when n is even like this. When n is even, we have observed that cos square theta or cos power 4 theta belongs to 0 to 1 closed interval. Therefore, okay, and cos power n theta belongs to, okay, minus 1 to 1 when n is odd like this. Okay, fine. Therefore, we have got here when n is even for cos power n theta also minimum value is 0 and maximum value become 1. When n is odd, the minimum value become minus 1 and the maximum value become plus 1, right? Okay, fine. Now the extreme values of tan power n theta, where n belongs to the natural numbers like this. See here, tan power n theta, my dear students, we have observed that tan square theta when that is even like this belongs to all positive real numbers 0 to infinity like this, when n is equal to even like this, right, and tan power n theta belongs to minus infinity to plus infinity, right, because when n is odd we observed that this is what when n is odd we have observed like this. Therefore, when n is even, the minimum value, extreme values means minimum and maximum value. Minimum value is 0 and the maximum value become infinity, that is nearer to infinity like this. And when n is odd, the minimum value is minus infinity and the maximum value become plus infinity. We are having like this. Now, similarly, the extreme values of, see here, the extreme values of cot power n theta, okay, when n belongs to the natural numbers, right? When we are having like this now cot power n theta, this belongs to, right, when n is even, like same concept, it will be having positive real numbers, because cot square theta we have observed, right, 0 to infinity like this, right, and cot power n theta belongs to, right, open interval minus infinity to plus infinity when n is odd like this, when n is odd. Therefore, when n is even, the minimum value is 0 and the maximum value become infinity, and when n is odd, the minimum value is minus infinity and the maximum value become plus infinity, right? Now we have the extreme values of cosecant power n theta when n belongs to the natural numbers. This is now you are having here cosecant power n theta, okay, that belongs to, right, that belongs to, you see, actually cosecant theta we observed that it is from minus infinity to minus 1 and 1 to infinity when n is okay when n is odd. When n is even, like what we are having is 1 to infinity like this, 1 to infinity when n is even, because minus 1, minus 2, minus 3, minus infinity, those are all power even number will once again positive numbers and it will become like this. And minimum value is 1 and maximum value is nearer to infinity. And cosecant power n theta belongs to, right, this is minus infinity to minus 1, right, union 1 to infinity, right, when n is odd, like this, when n is odd. That means the minimum value become minus infinity, nearer to minus infinity, and the maximum value become nearer to plus infinity. Now the last one, 24th one, we are having here these extreme values of secant power n theta will be the same as like cosecant. You see here secant power n theta, this is also secant square theta. We observed that this belongs to closed interval. It is same as like cosecant power n theta, like when n is even, like this. Okay, now this is minimum value is 1 and maximum value become infinity, and secant power n theta, this belongs to, you know, minus infinity to minus 1, right, union 1 to infinity when n is odd. That means the minimum value is minus infinity and the maximum value become plus infinity. Like this we are having the extreme values of 6 trigonometric functions and their powers when n is even and n is odd. We have generalized like this, right? Now see a wonderful result. Extreme values of a cos x plus b sin x are, this is what right, minimum, and this is what maximum value. That means what we require to prove is minus root over a square plus b square. This is what minimum value of a cos x plus b sin x, right? This is what we require to prove. That is what I am writing precisely. Okay, root over a square plus b square. The extreme values of a cos x plus b sin x are minus of root over a square plus b square comma root over a square plus b square. Okay, how we are going to get, and this also precisely we can write it as the range of a cos x plus b sin x is equal to, okay, the range, this one belongs to, this belongs to closed interval minus of root over a square plus b square comma root over a square plus b square, like this, right? Now we will prove this, how we are going to get this one, of course, right? You see, my dear students, here you take this function as something like f of x. You just give some name to this, like this, okay? F of x as some name you are giving to this. A cos x plus b sin x you are having here, of course, right? My dear students, what I am going to tell you is, for this, you take this constant a equal to some r into cos theta, because a and b are here real numbers, they are constants. A comma b belongs to r, they are real numbers. Now this real number a, you can write it as r into cos theta, some other constant into cos theta. Any constant a we can able to write in mathematics as some other constant times of cos theta. This is possible in mathematics, right? And similarly b is equal to r into sin theta. Another constant b, which is real number, that is also we can write it as r, some other constant times of sin theta we can write. Why we are writing like this? Because now you are going to get the benefit out of it, right? Why we are writing now this f of x is equal to, because a means we are able to write like this, r cos theta. This is r cos theta into cos x, plus b is r sin theta into sin x. We are having like this. We can take r common and this become cos of, right, cos of cos a cos b plus sin a sin b, cos a minus b, cos theta minus x we are having like this, right? Now f of x is equal to, we have got like this. And one more thing, they given to us a equal to r cos theta and b equal to r sin theta means let us do a square plus b square. Okay, we will do this one. Then what we are going to get is r square cos square theta plus r square sin square theta, right? If you take r square common, you are going to have cos square theta plus sin square theta for this, right? That means you have got this is r square into 1 like this, that is r square. That implies we have got r square equal to a square plus b square Therefore, you see, my dear students, r is equal to square root of a square plus b square. We have got from this r equal to root over a square plus b square. We have got like this. Now you see, my dear students, actually cos of theta minus x, whenever you are having cos of anything within the angle, you know that it is lying between -1 and 1 like this. But our function is what? R into cos theta minus x. Therefore, you multiply r on both sides. That's why minus r lesser than or equal to r into cos of theta minus x. This is what our function lesser than or equal to r like this. Minus r means now only we have got minus root over a square plus b square lesser than or equal to r into cos theta minus x. This is nothing but this. This is nothing but this. This is nothing but this. That is nothing but actually a cos x plus b sin x, our function, right? B sin x lesser than or equal to root over a square plus b square we have got like this. Root over, see, this is what? Lesser than or equal to, we have got a square plus b square. That means the minimum value we have got, the extreme values they ask you to find. Therefore, this is what the minimum value, and this is what the maximum value we have got, my dear students, like this, right? Wonderful result. Based on this, we are having a very beautiful problem, so that we are going to discuss now. See, next we have, based on the previous result, the extreme values of a cos x plus b sin x plus c are c minus root over a square plus b square and c plus root over a square plus b square. That means a cos x plus b sin x plus c is lying between these two values. That means this is the minimum value and this is the maximum value. That is what we require to prove. You see, my dear students, now only we proved that a cos x plus b sin x, whose extreme values, the minimum value is nothing but minus of root over a square plus b square, and the maximum value is nothing but root over a square plus b square, like this, right? Fine. Now they are adding a constant c on all the sides like this. Therefore, what you are going to get is a cos x plus b sin x plus c. Okay. Here c you add for this also, c minus root over a square plus b square, and here also you add c. This is okay. We have got c plus root over a square plus b square. Therefore, this is what the minimum value of this, and this is what the maximum value we have got. Therefore, we have got the range of this a cos x plus b sin x plus c, that belongs to the range. Means, you see, my dear students, c minus root over a square plus b square, comma, you are having here c plus root over a square plus b square, like this. This is what the range we have got for this result, right? Now see, my dear students, 27 extreme values of a cos of some function is alpha x plus beta plus b sin of alpha x plus beta plus c you are having here. Here where a, b, c are constant, alpha, beta are also constant. Then whose extreme values are c minus root over a square plus b square and c plus root over a square plus b square. The same logic will be applying here also, my dear students. You will be taking, okay, instead of x you are having alpha x plus beta, some compound angle. Even whatever angle is present within, okay, within cos and sine, you will apply the same method and same proof. You are going to get c minus of root over a square plus b square lesser than or equal to a cos of alpha x plus beta. Whatever may be the angle you are having, you will be getting the same thing, b sin of alpha x plus beta plus constant lesser than or equal to c plus of root over a square plus b square. That means this is what you have got the minimum value, and this is what you have got the maximum value, right? Minimum and maximum values are these. This is just a corollary of the main result. That means it is a sub result based on the main result, right, my dear students, like this. Now we have immediately one problem, my dear students. Based on this, find the extreme values of 3 sin x minus 4 cos x. Let us write this in the form minus 4 cos x plus 3 sin x, like this, right? This is something, it is in the form a cos x plus b sin x, like this. a cos x plus b sin x. That means a equal to minus 4, b equal to 3. And we know that the minimum and maximum values are, now only we discussed that, minus root over a square plus b square lesser than or equal to a cos x plus b sin x, right? That is lesser than or equal to root over a square plus b square, like this. Now this is minus root over a square means minus 4 whole square plus b square is 3 square lesser than or equal to, we have here minus 4 cos x plus 3 sin x, right? This is lesser than or equal to root over minus 4 square plus 3 square, like this. This is minus of 16 plus 9, this is minus root over 25, and this value is what? Minus 5 lesser than or equal to minus 4 cos x plus 3 sin x lesser than or equal to 5. Therefore, the minimum value, the extreme values, this is what the minimum value you are having, and this is what the maximum value you have got for this particular problem, like this. Okay, you will be doing using our result, you will be doing the problems like this. Okay, now the second problem, find the extreme values of 5 sin x plus 12 cos x plus 13, right? This we write it as 12 cos x plus 5 sin x plus 13, like this, right? This is of the form something like a cos x plus b sin x plus c, like this. That means we have here got a equal to 12, right? A is 12, b is 5, c is 13, like this. A is 12, b is 5, c is 13. And we know that okay, the extreme values of this is nothing but c minus root over a square plus b square lesser than or equal to a cos x plus b sin x plus constant. This is lesser than or equal to, right? What you are going to have is c plus root over a square plus b square, like this. Now let us substitute this only. Okay, now this is 13 minus root over a square plus b square, 12 square plus 5 square lesser than or equal to our problem. Now 12 cos x plus 5 sin x, right, plus 13, right, lesser than or equal to, right, 13 plus root over 12 square plus 5 square, like this. Now this is 13 minus 144 plus 25, root over 169. Root over 169 is what? 13 only. This is lesser than or equal to, we have got now 12 cos x plus 5 sin x plus 13 lesser than or equal to 13 plus 13, that is 26 here. And this is here 0. Therefore, 0 is lesser than or equal to our problem 12 cos x plus 5 sin x plus 13, that is lesser than or equal to 26. Therefore, this is what you have got the minimum value, and this is what the maximum value you have got. Minimum and maximum values are these. These are the what? Extreme values. Now we have find the extreme values of sin x plus cos x. You see, my dear students, this problem also you are having here something like a cos x plus b sin x. If we write like this, this is something like you have cos x plus sin x, right? When you compare, this is 1 into cos x and this is 1 into sin x. That means a value is 1 and b is 1. Therefore, this is minus root over a square plus b square, 1 square plus 1 square lesser than or equal to, you are having here cos x plus sin x, cos x plus sin x lesser than or equal to root over 1 square plus 1 square. This is now minus root 2 lesser than or equal to cos x plus sin x, and this is lesser than or equal to root 2. Therefore, this is what the minimum value, my dear students, and this is what the maximum value of this. Minus root 2 is the minimum value and root 2 is the maximum value, and these are the extreme values of this function, right? Next we have find the extreme values of sin x minus cos x, right? This also, if you arrange like this, a cos x plus b sin x, my dear students, this is now minus cos x minus 1 into cos x plus 1 into sin x, like this we can write. Here a value is minus 1 and b value is 1. Therefore, the extreme values what you are going to get, minus square root of minus 1 square plus 1 square lesser than or equal to our problem minus cos x plus sin x, right? And sin x minus cos x both are same. This is lesser than or equal to minus 1 square plus 1 square. This is now minus of root 2 lesser than or equal to, you have got now sin x minus cos x, otherwise this is root 2. Therefore the minimum value is this. This is what the minimum value and this is what the maximum value you have got. Therefore the range is nothing but, range means what? Minimum value comma maximum value. Okay, closed interval minus of root 2 comma root 2 you are having like this. Therefore this is what the range of this function. Now we have, my dear students, find the extreme values of sin square x plus cos square x, right? This thing how we do is, actually you know that in trigonometry sin square x plus cos square x, it is a square relation. This is always 1. Therefore the minimum value is equal to 1 and the maximum value also will be equal to 1, right? Sin square x plus cos square x equal to 1, where x is any real number. When x is any real number, we are going to get this. This is minimum value and maximum value become 1. Now, my dear students, the sixth problem, find the extreme values of sin square x minus cos square x. You are having like this. How we are going to find the extreme values of sin square x minus cos square x? Right? For this, see, my dear students, I am going to use the sin square x minus cos square x. We can write it as minus of cos square x minus sin square x. We can write, right? And this is equal to actually minus cos 2x. Okay? Because you know that cos 2x is equal to, my dear students, this you can write as cos x plus x. This is from multiple angles, cos a plus b formula. This is now cos a cos b minus sin a sin b, like this, right? That means you have got here cos square x minus sin square x, like this, right? Cos 2x, we have got a nice formula now like this, cos square x minus sin square x, right? This is the one. And also from this problem I want to tell you, cos 2x we are having actually 4 formulas. Those we will be, okay, now we will deal these things. Now we have got cos 2x is equal to, actually, my dear students, cos square x minus sin square x. Suppose I want, this is one formula, I want purely in terms of sine. Then what I will do is, this cos square x we convert into 1 minus sin square x minus sin square x, like this. Now this become 1 minus 2 sin square x. This is the, actually this is the first formula and we have got this as the second formula, like this, right? Now I want this purely in terms of now cos. That means what I do is, here we are having now cos square x minus sin square x, that we convert into 1 minus cos square x, right? The sin square x you purely convert into cos. Then what we are going to get is, this is cos square x, right, minus 1, minus into minus plus, this is now cos square x, right? Cos square x plus cos square x, that is 2 cos square x minus 1, 2 cos square x minus 1. We have got nicely, okay, this is what the third formula, this is the third formula, right? And also the fourth formula, we are having a cos 2x equal to 1 minus tan square x by 1 plus tan square x, like this, right? This also, if you observe that 1 minus tan square x means this is now sin square x by cos square x, whole thing divided by 1 plus sin square x by cos square x. You are having like this. Now if you take LCM, what we are going to get is cos square x minus sin square x by, okay, cos square x, whole thing by, now this is cos square x plus sin square x, whole thing by cos square x. You are having like this. Now this cos square x will cancel and cos square x plus sin square x become 1 and this become cos square x minus sin square x, right? This is, however, cos 2x formula. Totally we have got, my dear students, there are 4 formulas. This is what the fourth formula you are having. 1, 2, 3, 4. Totally we have got here 4 formulas. By using this occasion, we have got now these 4 formulas, right? Fine. Now you see, once we have got this now, okay, our thing is now minus cos 2x. We know that cos 2x will always lies between minus 1 and 1 like this, right? Fine. Now we want minus cos 2x. That means you just multiply minus sign on both sides. This is 1. Then inequality will be reversed. Lesser than or equal to minus. See, this lesser than or equal to will become greater than or equal to. And cos 2x, this is greater than or equal to minus 1. Now if you write this in proper way, this is now minus 1 lesser than or equal to cos 2x lesser than or equal to 1. Once again, we have got this, right, minus cos 2x. The minimum value is minus 1 and the maximum value become plus 1. The minimum value is minus 1 and the maximum value become plus 1. We have got in this beautiful way. See, my dear students, now the extreme values of sixth one, cos power 4x minus sin power 4x. Okay, part A. And B, sin power 4x minus cos power 4x, which is negative of the other one. How we are going to do this particular one? You see, my dear students, the first one, A part, cos power 4x minus sin power 4x. Right? This we can write it as cos square x whole square minus sin square x whole square like this. Now this becomes, of course, cos square x minus sin square x into cos square x plus sin square x. Cos square x plus sin square x you are having. And this is, of course, 1. And this is now, we already proved this is cos 2x. Therefore, the extreme values, what you are going to get, minus 1 lesser than or equal to cos 2x lesser than or equal to 1 like this. Right? When let us come to the B part, this is actually sin power 4x minus cos power 4x. Cos power 4x, right? This is equal to minus of cos power 4x minus sin power 4x like this, right? And this only we have got it as cos 2x. This is now minus cos 2x we are going to get, right? Already we know that cos 2x lies between minus 1 and 1. Minus cos 2x, that becomes, if you multiply minus sign on both sides, greater than or equal to, this is now minus cos 2x greater than or equal to minus 1, right? That implies now minus 1 lesser than or equal to, we can write, see, this is 1 greater than or equal to minus cos 2x greater than or equal to minus 1. That means minus 1 lesser than or equal to cos 2x minus cos 2x lesser than or equal to 1. Therefore, the minimum value is minus 1 and the maximum value become plus 1 for this also. Like this we will do this beautiful problem, right? See, now we are having here, my dear students, sin power 4x plus cos power 4x, right? We are going to use the formula a square plus b square is equal to a plus b whole square minus 2ab like this, right? Now this one, sin power 4x, we can write as sin square x whole square plus cos square x whole square like this, right? A square plus b square. This equal to, now we can write this as sin square x plus cos square x whole square minus 2ab. 2 into sin square x into cos square x like this. Now sin square x plus cos square x become 1. 1 square minus 2 sin square x cos square x. You are having like this. Right, my dear student? Now I will write this as, okay, 4. I multiply and divide by 2. Then you will be getting 4 sin square x cos square x whole by 2 like this. Right? And you know that 1 minus 4 sin square x cos square x is nothing but, we can write it as 2 sin x cos x whole square by 2 like this, right? And this is, of course, 1 minus 2 sin x cos x is nothing but sin squares. Okay, this is sin 2x whole square by 2 like this. Okay, sin 2x whole square, because you know, my dear students, you know that sin 2x, how you are going to get this, you can write it as sin of x plus x, sin a plus b formula. That means sin a cos b plus cos a sin b, cos x plus sin x like this. This is, however, 2 sin x cos x. We have got sin 2x is nothing but 2 sin x cos x. That is what I substituted, and whole square is nothing but sin square 2x. Right? Now, what we are going to do, is sine square 2x we are having here, and already I told you, my dear students, cos 2x is equal to 4 formulas. Among them 1 minus 2 sine square x is one of the formula. If I subject sine square x here, right, what I am going to get is, you see my dear students, 2 sine square x equal to 1 minus cos 2x, and sine square x is nothing but 1 minus cos 2x by 2, like this, right? I can use this formula now. Now in the place of x we are having 2x, therefore it becomes 1 minus of we are having here, like this, we will write here. Of course there is no space here. 1 minus cos 2 into 2x, that becomes 4x by 2, right, whole by 2, like this. Sine square 2x I can write as 1 minus cos 2 into 2x by 2 into 1 by 2. We are having like this, right? Now this, what we do is here, right, 1 minus of this is now 1 minus cos 4x by 4, like this, right? And if you take LCM here, 2 into 2 4, 4 minus 1, minus into minus, plus cos 4x by 4, like this. Now 4 minus 1 is 3, 3 plus cos 4x by 4, we are having like this, right? And you know that cos 4x, right, cos 4x values lies between minus 1 and 1, like this, right? And I add 3 to that, 3 minus 1 lesser than or equal to 3 plus cos 4x lesser than or equal to 1 plus 3, like this, right? And that, see, I am writing here, since there is no space, 3 minus 1 is 2, 2 lesser than or equal to 3 plus 4 cos x, sorry, 3 plus cos 4x, right? Yes, cos 4x lesser than or equal to 1 plus 3 become 4, you are having that as 4, like this. Now whole thing divided by what we are having, 4, therefore 2 by 4 lesser than or equal to 3 plus cos 4x by 4 lesser than or equal to 4 by 4, right, like this. 2 by 4 is what, 1 by 2, 1 by 2 lesser than or equal to 3 plus cos 4x by 4 lesser than or equal to 1. That means the minimum value is, you have got 1 by 2, and the maximum value you have got it as 1. Minimum value is 1 by 2 and the maximum value become 1. You have got nicely by using this formula. A square plus b square is equal to a plus b whole square minus 2ab, right? Now 8th one, find the extreme values of sine power 6x plus cos power 6x, my dear students. For this we are going to use a cube plus b cube equal to a plus b whole cube minus 3ab into a plus b formula, like this, right? Now we have taken sine power 6x plus cos power 6x is equal to, this is now sine square x whole cube plus cos square x whole cube, we can write. Something you take here a as sine square x here, like this, and b as cos square x you take like this, right? Now a cube plus b cube equal to a plus b whole cube minus 3ab into a plus b, like this, right? If you take a equal to sine square x and cos square x, that means you see, we have got this as sine power 6x plus cos power 6x as 1 cube minus 3 sine square x into cos square x into 1, like this. This is now, we have got totally sine power 6x plus cos power 6x is equal to 1 minus 3 sine square x cos square x, 1 minus 3 sine square x cos square x, right? Now to apply sine to x formula, what I do is I multiply 4 and divide by 4, 3 sine square x cos square x, we are having like this. Okay, we multiply and divide by 4, like this. Now this equal to 1 minus 3 into this, we can write as I told you, 2 sine x cos x whole square, like this. Whole thing by 4, like this, and this equal to 1 minus 3 into 2 sine x cos x is sine to x whole square is nothing but sine square 2x whole by 4, like this. We are having like this, right? And of course, as I told you that this we can write something using 1 minus this, we can write it as, of course you can take LCM. This is now 4 minus 3 sine square 2x whole by 4 like this. Now this is 4 minus 3 into, I told you that sine square theta equal to 1 minus cos 2 theta by 2. Therefore, this is now 1 minus cos 2 into 2x, that is 4x by 2. We can write like this. Whole thing, okay? This is what you are having here, and whole thing by 4 you have like this, right? Now this becomes, if you take LCM here, this becomes 8 minus 3 minus into minus plus 3 cos 4x by 8 we will be getting here, of course, by taking LCM 2 here, and 2 into 4 become 8 like this. Now this is 5 plus 3 into cos 4x by 8. We have like this, right? Now you see, my dear students, how we are going to get the extreme values. You know that cos 4x lies between minus 1 and 1 like this. If you multiply 3 to that, then what you are going to get? 3 cos 4x, okay, minus 3 lesser than or equal to 3, right? Now you add 5 on both sides. Now 5 minus 3 lesser than or equal to 3 cos 4x plus 5 lesser than or equal to, right? You have got 3 plus 5 like this. Now 5 minus, now divided by 8, this is divided by 8, this is divided by 8, this is divided by 8. 5 minus 3 is how much? 2. 2 by 8 is 1 by 4 lesser than or equal to, this is what? 3 cos 4x plus 5 by 8 lesser than or equal to 1. That means the minimum value, the extreme values, this is what the minimum value you have got, and the maximum value is 1. Okay, minimum value you have got, my dear students, as 1 by 4, and the maximum value you have got it as 1. Like this beautiful problem we can solve. Therefore, we have got that 1 by 4 lesser than or equal to sine power 6x plus cos power 6x lesser than or equal to 1. Like this we can do. This is what the result. We can use this as like a result also. Now we have the ninth problem. Find the extreme values of sine square 60 degrees plus x plus sine square 60 degrees minus x, right? How? Now only we told you that one formula, sine square theta equal to 1 minus cos 2 theta by 2, like this. We are going to use this formula, right? Fine. Now sine square 60 degrees plus x plus sine square 60 degrees minus x, this is equal to 1 minus cos 2 into, right, 60 degrees plus x whole by 2 plus 1 minus cos 2 into 60 degrees minus x whole by 2, because in the place of theta you are having 60 degrees plus x, right? Now what you do is you take 2 as LCM here. Now 1 minus cos 2 into 60, that become 120 degrees plus 2x. Okay, this is 1 plus 1. Okay, however we write like this, plus 2, right? Fine. 1 plus 1 we have here 2, like this. 1 plus 1 2, and this is now minus cos of 120 degrees minus 2x, like this, right? Fine. By 2 we have here. Now 2 minus, if you take common, this is cos 120 degrees plus 2x plus minus you took common, that's why cos 120 degrees minus 2x whole thing by 2. You have got the whole thing by 2, like this. You know, my dear students, one thing, cos a plus b, look here, cos a plus b plus cos a minus b. That is nothing but, if you observe, this is 2 cos a cos b. Okay, you write the formula and cancel, then you will get 2 cos a cos b. That means now this is 2 minus 2 into cos a. Cos a is nothing but cos 120 degrees, cos b is nothing but cos 2x whole by 2, like this. Now this equal to 2 minus 2 into cos 120 degrees, you know that cos 90 plus 30 minus sin 30, that is minus 1 by 2. Minus 1 by 2 into cos 2x by 2, like this. Now 2 will cancel, minus into minus plus, you have got this as now 2 2 plus cos 2x, 2 plus cos 2x by 2, like this. Right, now for this we need to find the minimum and maximum value. Now cos 2x, you know that, my dear students, it lies between -1 and 1, like this. Now we add 2 to this. Now 2 minus 1 lesser than or equal to 2 plus cos 2x lesser than or equal to 1 plus 2, like this. Right, now you divide by 2, you divide by 2, like this, you divide by 2. 2 minus 1 is 1, 1 by 2 lesser than or equal to your problem 2 plus cos 2x by 2 plus 3 by 2, you have like this. Right, now the minimum value is, you have got, this is what the minimum value, and you have got, this is what the maximum value. Minimum is 1 by 2 and maximum value is 3 by 2. Like this we will get this beautiful problem. Right, now see, my dear students, the 10th problem we are having, the last problem of this video. We have given that find the extreme values of cos x, cos pi by 3. Pi by 3 means 60 degrees. 180 degrees by 3, that is 60 degrees. Now cos x, cos 60 degrees plus x into cos 60 degrees minus x, you are having like this. Right, we need to find the extreme values of this. Now this become cos x into cos a plus b into cos a minus b. This is now cos square a minus sin square b. Cos square 60 degrees minus sin square x, like this. Right, this equal to now cos x into cos square 60, that is 1 by 4 minus sin square x. Right, now let us convert everything into, right, cos x. Now this is 1 by 4 minus sin square x, we can write as 1 minus cos square x, like this. Right, this equal to now cos x into, right, 1 by 4 minus 1 minus into minus plus cos square x, like this, like this. Right, now this is cos x into 1 by 4 minus 1, that become minus 3 by 4 plus cos square x, like this. Right, and this becomes now cos x into minus 3 plus 4 cos square x by 4, like this. Right, now this is equal to, if you multiply this to this, what you are going to get? Cos x inside, we will get 4 cos cube x minus 3 cos x by 4, like this. Now 4 cos cube x minus 3 cos x is what? Cos 3x formula, cos 3x by 4, like this. Right, now we need to find extreme values. You know that minus 1 lesser than or equal to cos 3x lesser than or equal to 1 for cos. Now you have to divide by 4, divided by 4, divided by 4. Therefore the minimum value you have got for this is minus 1 by 4, and the maximum value you have got as 1 by 4, like this. Minimum value you have got it as minus 1 by 4, and the maximum value you have got it as plus 1 by 4. Therefore this is the range of this function, like this. Right, my dear students, the minimum is minus 1 by 4 and the maximum value is 1 by 4. This is what, therefore this function is belongs to, right, cos x into cos pi by 3, right, plus x, cos pi by 3 minus x belongs to means the range is from, okay, closed interval minus 1 by 4 comma 1 by 4, like this. We have got this particular problem. Okay, my dear students, you please go through this video nicely, write the concepts clearly in your notebooks such that you will be perfect. Right, thank you very much. Please subscribe and share to your friends.